All right, so this is just an introduction to the Laplace transforms and how to actually find some. So we have the definition of Laplace transform of a function y of t. Um, it's an improper integral from 0 to infinity of function times e to the negative s t dt. So we will end up with a function of s. So, I mean, just looking at a very basic function like 1, that would be the same as the integral from 0 to infinity of 1 times e to the st, e to the negative st, I'm sorry. So this is just the integral of e to the negative st. So with respect to t, s is like a constant. So we end up with a negative e to the negative st all over s. And we're going to evaluate from t equaling 0 and as t approaches infinity. So with improper integrals, we're just utilizing limits to evaluate endpoints, I guess. What do we get? So we have to look at the limit as t approaches infinity of a negative e to the negative st over s. And then subtract or add, in this case, subtract a negative, so add e to the negative s times 0 would just be 1. So this would be 1 over s. So this limit is very important, and we run into it a lot with Laplace transforms. And you notice it's dependent on the value of s. So if I have a power of e, the only way it can converge is if e is to a negative power. So this limit would converge if s is greater than 0. So if s is greater than 0, then the power on e is negative. As t goes to infinity, that would approach 0. But it diverges otherwise. It diverges. Obviously, it's not defined at s or at 0, so s cannot be equal to 0. But as I approach 0, um, excuse me, the limit as t goes to infinity, if this was a positive exponent, or if s is greater than 0, then this would go off to infinity and the limit was diverged. So um, what we found is we have a restriction. So the Laplace transform of 1 is actually equal to 1 over s only if s is greater than 0. So just looking at this same thing, we can come up with generality, right? Um, Meaning we could take the Laplace transform of any constant, and that should be equal to, and because of the properties of integrals, if I just put in constant instead of 1 here, then we can just move the constant in front of the integral. So this would be the same as integrating c times the integral from 0 to infinity. So the only thing that changes is that we have a c times 1 over s, or this would be the same as c then over s. And again, as long as s is greater than 0. So Laplace transform of any constant then is just a function of s, c over s. So the next one